Now I'm going to show you how to find that Z-star value, the critical value, using technology. I'm going to focus here on the two values or the two methods that we use most in this class, which is the TI-84 and StatCrunch. But first, it's super important that you understand this part, otherwise the rest of it isn't going to work for you. So we're working with intervals, and we're going to leave a little bit on each side of our interval because we're capturing an interval. So there's a little bit left on the outsides. So if I'm using, say, a 90% interval, that's 10% on the outside, but that's 5% here and 5% here. Now, when I'm plugging this into either my calculator or StatCrunch, what I'm looking for is what's this number? What's this value? What's the area to the left of the curve? Area to left is what I'm looking for. And so in this case, if I had 5% on this side, and then this is 90%, then that means there's 95% to the left, or 0.95, not using a percentage. So again, 0.95 is the number that I'm going to use. Yes, I could plug in my 0.05, but I'm going to use the 0.95. So that's the number that I'm going to use using technology. So I want to show you how to do this on the TI-84 and also using StatCrunch. So if I'm using my TI-84, and again, we looked at the 90% confidence, which meant 0.95, then that means I would do second and vars. And it's the same place I go when I do my normal CDF, but I'm going to use inverse normal. So that's number 3. And then area is just the area to the left. So in this case, that's going to be 0.95, using 0 and 1. And then I paste and I find 1.645. So this is the one that I would be using. Again, let's say I was doing a 95% confidence interval. Well, that would mean that there's 2.5% on each side. So I would do the same thing, but instead of 95, I would do 0.975 because there would be 2.5% on each side. And so again, that's where I get the 1.96. So you can check any of the ones that I gave you previously, but just remember that I'm taking 1 minus that number and then half of that to find how much is to the right or to the left. To do the exact same thing using StatCrunch, which obviously is very helpful since StatCrunch is easily accessible for you as you're working in my stat lab, we're going to go to Stat, Calculators, and Normal. So again, I've already opened that up for you, but I would just go to Stat, Calculators, and Normal. And there I'm going to use a mean of 0 and a standard deviation of 1, just as I did before. And I'm going to use whatever that number is, whatever that percentile is, which is the 95. So here I'm going to plug in 0.95, and then notice here is where it computes the 1.645. Or the other example that we looked at, the 0.975, gives me 1.96 just as before. So remember that it's okay to put the value here and leave this one blank instead. I do want to actually show you one last way, and I didn't know this the first time I created this video, so I'm adding this on, and I think this way is far superior to the way that I showed you before. So previously, when we were doing this, we had to do this whole spiel where if it was a 90% interval, I actually had to use 0.95 because that was the value here. So instead, now I don't have to do that if I choose the correct option in StatCrunch. So I'm still going to Stat, Calculators, and Normal just as I did before, but now I'm going to click that between function. So notice previously when I did a 90% interval, I put in 0.95 and got 1.645 if I round to 3 places, which is pretty standard. Instead, if I go to the between function, if I'm doing a 90% interval as I did here, I'm going to just enter in 0.9. And notice that this also gives me 2 critical values, the negative value, which is the one here, and the positive value, which is the one here, 1.645, which is the same as we had previously. And I didn't have to do any math and figure out what number to put here because it's 90%. The other advantage is obviously that it gives me what the interval actually looks like. In addition, I could then find the 95% interval by clicking on 0.95, and again I get the same values I did before, and we would of course always use that positive value.